Standard 11 Chemistry Unit 4 Chemical Bonding and Molecular Structure Part 6. Here we discuss about bond enthalpy. Amount of energy is required to break 1 mole of bond between two atoms in a gaseous state, and it is called bond enthalpy. For example, here first of all, in a hydrogen molecule there is single bond between two hydrogen atoms. Here is single bond. How it will be formed? By sharing of 1 electron. If there are sharing 2 electrons, there are double bond. If there are sharing of 3 electron, there is triple bond. Here, to break this single bond, we required some amount of energy, and it is called bond enthalpy. To break this bond, we required energy is 435.8 kilojoule per mole. Here the amount of energy required to break 1 mole of bonds of particular type. Either they are single bond, double bond, or triple bond. Between two atoms in a gaseous state, and it is called bond enthalpy. Here hydrogen molecule is in a gaseous state. There is breaking of the single bond, and here 2 hydrogen atom. Its value, bond enthalpy value, is 435.8 kilojoule per mole. Another example, here the oxygen molecule is formed between two oxygen atom. Oxygen has 2 unpaired electron, and they are sharing 2 electrons, and they forms double bond. To break this bond, we required some amount of energy, and that energy value is 498 kilojoule per mole. Here in a single bond, here there is single bond between two hydrogen atom, we required 435.8 kilojoule per mole. Here between two oxygen atom there is double bond, and its value is 498. It is little bit higher. Here the oxygen atom. For nitrogen molecule, here one nitrogen atom has 3 unpaired electron. They shares 3 electron and they forms triple bond. To break this bond, we required some more amount of energy. Here nitrogen molecule is nitrogen atom and the energy is required and its value will be 946 kilojoule per mole. Here as the bond is increases from single bond to double bond to triple bond, bond enthalpy is increases. Here as the number of bond between two atoms increases, it means here single bond, double bond or triple bond, number of covalent bond between two atoms is increases, their bond length will decreases. Bond length decreases, but their bond enthalpy increases. Here bond enthalpy value in a hydrogen molecule is less than oxygen, is less than nitrogen, or bond length value is high in a hydrogen molecule is greater than oxygen, is greater than nitrogen. It's most important for MCQ also. Now the second concept is for polyatomic molecule. For example, water molecule is polyatomic molecule because here there are 3 atoms, 2 atoms of hydrogen and 1 atom of oxygen. Here is the central atom, here 2 hydrogen atom. This to break this bond we required energy. To break this bond we required another amount of energy. Here in the first step, this bond will break here and its value is 502 kilojoule per mole. In the second step, here the bond will break between oxygen and hydrogen atom. Second step, oxygen and hydrogen. Now its value, bond enthalpy value is little bit decreases, and its value is 427 kilojoule per mole. So we get two different value of bond enthalpy. For this oxygen hydrogen bond enthalpy, there is an average value 502 plus 427 divided by 2 is 9, is 2 922 point sorry 929 divided by 2, and its value will be 464.5 kilojoule per mole approximately. Therefore, in a polyatomic molecule, that is average bond enthalpy will be used. Now the fourth bond parameter, that is bond order. Here in a covalent bond, the bond order is given by the number of bonds between two atoms in a molecule. That means here, if there is sharing of 1 electron, there is single bond. Sharing of 2 electron, double bond is formed. Sharing of 3 electron, triple bond is formed. Is there number of bond between two atoms in a molecule, and it is called bond order. For example, here in a hydrogen molecule, there is single bond between two hydrogen atom, single bond. Now its bond order will be 1. In a oxygen molecule, there is double bond between two oxygen atom, and its bond order is 2. In a nitrogen molecule, there is triple bond between two nitrogen atom, and its bond order is 3. In case of isoelectric molecules or ion, isoelectric, that means molecule or ion containing same number of electrons. For example, fluorine molecule and oxide ion O2 2 minus. Here between two fluorine atom, there is single bond. Here the oxygen, two oxygen atom is also is isoelectric species. Its bond order will be 1. And same thing is here, nitrogen, carbon monoxide or nitrosonium ion is called nitrosonium ion. These all are isoelectric species because here in a night there are two nitrogen atom. There is 7 electron, 7 plus 7, total 14 electron. Same thing is here for carbon 6 and oxygen 8. Here 6 electron and here the 8 electrons. Total number of electrons are 14. Same thing is here because in a nitrosonium ion there is 7 electrons, in a nitrogen 8 electrons, in oxygen and plus 1, that means less than 1 electron. 7 plus 8 15, 15 minus 1 14 electrons. These all are isoelectric species. And their bond order, here in nitrogen atom there is triple bond, so their bond order will be 3. And the last, that is very most important for examination aspects, is the bond order increases, bond enthalpy is increases, but bond length will be decreases. So the relation between bond order, bond enthalpy and bond length is bond order is directly proportional to bond enthalpy is inversely proportional to bond length is directly proportional to the stability of molecule. This is most important. And here the another example for carbon dioxide is a carbon is a central atom which is bonded with two oxygen atom with double bond, and the bond order is 2. Ethene molecule, there is double bond between two carbon atom and its bond order is also 2. Okay, so friends, this is the concept about bond order, bond enthalpy, bond length. Next time we will discuss another topic. Thank you very much.